Hello students, in the last topics we have covered about the Gay-Lussac's laws, Boyle's law and Charles law. Today again I am just going to tell you about the stoichiometry and Avogadro's law. Now, what is the meaning of stoichiometry? I am just introducing the definition of stoichiometry. It is the branch of chemistry that deals with the quantitative relationship between the amounts of reactant and product in a chemical reaction. For example, carbon plus oxygen reacts combine to form carbon dioxide. So carbon and oxygen both are the reactant and the product is carbon dioxide. So in which quantity the carbon and oxygen is going to be used to form the product carbon dioxide, that its study is known as stoichiometry, or in simple terms it allows us to calculate how much of a substance is needed or produced in a chemical reaction based on the chemical equation. It is a part of these laws. So we are going to again discuss about the key concepts of stoichiometry. First is the mole ratios, which is derived from the balanced equation. For example, over here I have written over there that is 2H2 plus O2 gives you 2H2. It means 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. Or we can say that C plus O2 gives you CO2. It means 1 mole of carbon reacts with 1 mole of oxygen to form 1 mole of carbon dioxide. It also helps in the different types of calculation. For example, mass to mass ratio. 1 mass of the reactant is given, we can calculate the product mass also, or mass of the two reactant we can be calculated on the basis of that only. Mole to mole ratio, if the equation is given in the form of mole, then another product in the moles can be calculated. Or mass to volume, if sometimes what happens, the solid products are going to be used and they are going to produce the gaseous, so we can calculate the mass to volume relationship, and basically mass to volume is going to be used for the gaseous product. So here two laws are coming over here. One is the law of conservation of mass. What does the law of conservation of mass tell us? That is total mass of reactant equal to the total mass of product in a chemical reaction. Means neither the mass is created nor the mass is, you can add it over here, neither the mass can be created nor mass can be destroyed, but it can change its form from one form to another. Reaction stoichiometry is what? It is also the study of quantitative relationship among substances during a chemical reaction. Quantitative relationship, like we have done the stoichiometry. So if we are going to deal the stoichiometry in the terms of the chemical reaction, then its study is known as reaction of stoichiometry. Now we are going to study about over here again another law, that is the Avogadro's law. Avogadro was a scientist who has given on his name only that this law has been derived. What does it state? That it states that equal volume of gases at same temperature and pressure have an equal volume of molecules, or we can say that equal volume of all gases contain equal number of molecules at the same temperature and pressure. You can modify it and you can do it. Here, if we are going to introduce the formula over here, then V upon N is equals to K. What is V? V is the volume of the gas and N is the number of moles of the gas which is going to be used in the chemical reaction. And what is K? When they are both are going to be divided, volume and the mole are going to be divided, then it gives a constant which is in which two conditions are going to be taken, that is temperature and pressure, then it gives the value of K constant. Now, where this law can be used, we can say that implication, where we can be applied to this law. At constant temperature and pressure, doubling the number of moles doubles the volume. Means temperature and pressure are going to be constant, then the volume is directly proportional to the moles. So it means if volume is going to be doubled, then moles are also going to be doubled. Now, this also support the concept of mole and form the basis of molar volume. Molar volume means it is the standard volume which is taken in concepts of the liquid. So this also support the mole and forms the basis of molar volume. At standard temperature and pressure, which is known as STP, 1 mole of ideal gas occupies 22.4 liters. Now, for example, as I have told you in the Gay-Lussac's law, that temperature is going to be taken, standard temperature is going to be taken in the form of Kelvin, and the pressure is going to be taken, pressure I have not told you, but pressure is also going to be taken, standard pressure, that is also going to be taken in the form of ATM or atmospheric pressure, and also the 760 millimeter of Hg or 76 centimeter of Hg or 760 torr. All these are the base standard pressure which is going to be used over here. Now, importance. What is the importance of this law? It is crucial for understanding gas behavior and is foundational in stoichiometry in involving gases. That is, it is understanding the gas behavior. What happened when we are increasing the pressure or keeping the pressure and temperature constant. If we are increasing the volume, so what happens to the moles and their ratio, they are going to be tell in this way. Now, on the basis of this, that you know that sometimes if I am going to write the sodium is going to be written in as Na, but oxygen, if I am going to write the oxygen gas, it is written as O2. Why the sodium is only simple Na and oxygen gas is taken as O2? It means that sodium atom can exist independently. Their atoms are too big to exist independently, but the oxygen atom, they are too small, that's why they are going to combine to form O2. So here I'm just introducing the term atomicity also. So what is this atomicity? Atomicity is the number of atoms present in single molecule of element or compound. For example, atomicity, word has taken from atoms. Atomicity, it means number of atoms present in single molecule. One molecule. Molecules, you know it already, that it is the smallest substance of the matter which can exist independently. The single we are going to, I'm just keeping the pressure over here, that it is a single molecule of an element or compound. There are different types of atomicity. One is the monoatomic, that is for the elements. I'm just types of atomicity for the basis of elements. Monoatomic, 1 atom per molecule. Mono means 1, atom means atoms. Mono means 1. So example, like inert gases, helium, neon, argon, all these are noble gases. They are not going to be diatomic, they are singly, their atoms are too big, they can be used, they can be monatomic in nature. Diatomic means 2 atoms per molecule. For example, oxygen O2, hydrogen H2, nitrogen N2 and chlorine Cl2. Now, next is the triatomic. Tri means 3, atom again means atom, means 3 atoms per molecule. Example, ozone. In the same way, tetraatomic, octaatomic. I've written wrong over here. It is octaatomic. It is octaatomic. Let me correct it over here. Let me just see. Octaatomic. Octaatomic, for example, 4 or more atoms. Tetra means 4, atomic means atoms, octa means 8, and 4 or more atoms per molecule. Example, P4, white phosphorus, it is tetraatomic, and sulfur S8, which is known as, that is sulfur is known as octatomic. Now for compounds, atomicity is the total number of atoms in a molecule. It means atomicity can be based on the basis of the element as well as on the compound. So atomicity is the total number of atoms in a molecule. For example, if I am taking H2O, it means hydrogen 2 atoms, oxygen 1 atom, 2 plus 1 3, so it means 2 hydrogen atom, 1 oxygen atom makes total 3 atoms. Now on the basis of the types of molecules, if I am going to consider about the atomicity of molecules, the types of molecules, there are two types of molecules are there. One is the homoatomic molecule and second one is the heteroatomic molecule. Homo means same atom. When the same atom of the element get combined, it will form the homoatomic molecules. For example, phosphorus P4, S8, oxygen O2, ozone O3. So this means that homoatom made up of same type of atoms. Heteroatomic molecules means made up of several type of atoms. For example, I have taken over here the water. Hetero means made up of several types of atoms. For example, HCl, hydrogen 1 atom, chlorine 1 atom, atomicity is 2. Ammonia, NH3, nitrogen 1 atom, hydrogen 3 atom, means 3 plus 1, 4 atoms of ammonia is there. Now, so this is all about the atomicity. All these things we are going to use to in the numericals, finding the numericals, how to, the application means uses of Avogadro's law. Finding the molar volume of the gases. Molar volume means, I told you already, molar volume, 1 mole of an ideal gas occupies 22.4 liters, making volume to mole conversion straightforward. Okay, if it is given over there, then if standard volume we are going to take, then it is 22.4 liter. Calculating the number of moles from gas volume. We can also calculate the number of moles. If the gas volume is there given, then we can also calculate the number of moles also. Then afterward, given volume, temperature and pressure, you can calculate the number of moles using Avogadro's law. Now, understanding chemical reactions involving gases. Sometimes what happens, volume ratio of the gaseous reactant and product corresponds to mole ratio if temperature and pressure are kept constant. For example, nitrogen, 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. This is the concepts of mole. If I am going to take the volume like we have done in the Cayley-Stokes law, 1 volume of nitrogen reacts with the 3 volumes of hydrogen to produce the 2 volumes of ammonia. Now this also help in the figuring out of the molecular formula. It also help in the formation of the formulas, how the formula has been made. Combined with other gas laws, Avogadro law also helps to calculate molar masses and molecular formula of the gases. For example, molar masses, for example, ammonia, nitrogen, atom. If I am going to take the mass of an element, it is called the atomic mass. If I am going to take the mass of the compound, it is called the molecular mass. So for example, ammonia, nitrogen has the atomic mass 17, nitrogen has the atomic mass 14 and hydrogen has the atomic mass 1. So nitrogen 1 atom, 14 plus hydrogen has 3 atoms, 14 plus 3, that is 17. So in this way the molecular formula and molecular mass can be calculated. Molar mass or molecular mass can be calculated. Balloon and airbag design. It is also used to calculate the amount of gas needed to fill container under specific conditions. You know that in the airbags we are using in the cars also, that how much during the accident, how much that airbags are going to be open, or how much air is going to be filled, that is also help in the calculate how much gas is going to be filled in that one. That is also going to be calculated with the help of the Avogadro law. It also help in the biological reactions also, like the breathing and the respiration. It help to understand how gas volume changes with oxygen and carbon dioxide during respiration in biological system. You must have read in the bio that is the tidal volume, the molar volume, all these things are going to be calculated. So now in total we have just read about it, that is Avogadro law is the fundamental, what we have read. So this is a summary of this topic, that is Avogadro law is a fundamental principle for understanding gas behavior and is widely used in the laboratory, calculations, industrial application and scientific research. Now, so this way, whatever I have taught, that I have given you in the summary form. So here are a few examples of numerical problem which is based on the Avogadro law along with their solution. I have just given it over there. First example is, example number 1. A gas occupies 5 liters at a certain temperature and pressure. What volume will the gas occupy if the number of mole is doubled, assuming the temperature and pressure remain constant? So now what is given over here? 5 liter. 5 liter is the volume. And what they have asked? They have asked the volume. But the V1 upon formula was the, what was the formula? V upon N is equals to K constant. So I have taken two gases are here, the initial gas volume and the final gas volume we have to calculate it. So what we will do, V1 is 5 liter and nitro, how I have taken the N2, that is 2N1, because it is written a gas occupies 5 liter at certain temperature and pressure. What volume will the gas occupy if the number of mole is doubled? What happens to the volume when the number of mole is doubled? It means we are going to just, N2 is, what is N2? N2 is the second mole, means the final number of mole. Final number of mole is going to be doubled, that is, it is equals to 2N1, and what we have kept the constant, temperature and pressure is kept constant. So formula will become V1 upon N1 is equals to V2 upon N2. So we have to calculate the V2 by cross multiplication. V1 into N2 upon N1 is equals to, now putting the values over here we can put it V1 into N2. What is the value for the N2? 2N1, and N1 is simple N1 will be cut with the N1 and it will become only 2 over here. V1 is 5 liter, so 5.0 into 2 is equals to 10 liter. I think it is going to be understood by you people. I have not just, you can apply it over here and you can use it over there. Now, second example is, if 3 liter, 3 moles, first I have taken how to calculate the volume if the moles are given. Now I am going to calculate the that is again the number of volume again. We have to calculate the volume. If 3 moles of gas occupy 67.2 liters at a certain temperature and pressure, what volume will 1 mole of the gas occupy under the same condition? What is 3? 3 is the number of mole, means N1 is given. And what is the 67.2? It is the volume, that is V1. So V1 is 67.2 and N1 is 3 moles. Now, what volume will 1 mole of the gas occupy under the same condition? Means now the number of moles, we are just reducing it. That is, N if we are going to reduce, that is 1 mole. From 3 mole, we are just making it 1 mole. So how to calculate the volume? Then again the formula will be applied. I have told you. Here V2 is equals to V1 into N2 upon N1. What is N2? N2 is 1 and N1 is 3. Divide it, then it will become 22.4 liter. By cutting it, you can get it. So what you are just seeing in these equations, what happened if we are going to double the moles, the volume is going to be doubled. If we are just keeping the one third of the moles, the volume is also going to be 1/3. Now there is one more example that we are going to calculate over here. At constant temperature and pressure, 4 liters of nitrogen gas reacts with hydrogen gas to produce ammonia gas. Now, 4 liter means volume, and 4 liter of nitrogen gas reacts with hydrogen gas to produce ammonia gas according to the equation. Here equation is given. Here, if 4 liters of nitrogen react, what volume of hydrogen is needed? If nitrogen is 4 liter, then how much volume we are going to use? First, what we'll do, if the equation is given, I already told you in the Gay-Lussac's law, if the equation is not given, you have to write the equation. After writing the equation, you have to balance the equation. But here the equation is already given, so it is balanced. So 4 liters of nitrogen, from the equation is balanced, N2 plus 3H2 gives you 2NH3. So from the balance equation, volume ratio is equals to mole ratio of the gas. Here, how much volume we have taken for the nitrogen? We have taken 1 volume of nitrogen reacts with how much volume of hydrogen? 3 volume. So nitrogen over here is 4 volume, N2 is 4. So hydrogen is how much? Because for 1 volume, how much hydrogen is needed? 3 volume. For 4 volume of hydrogen, how much? 4 volume of nitrogen, how much hydrogen is needed? 4 into 3, that is 12 liter. No need to add this is the simple equations, you can use it. So how much? 12 liter is needed over here. Now, example 4, there is 4. That is a balloon holds 2 moles of helium gas at a certain temperature and pressure, and its volume is 44.8 liters. How much moles of helium gas are needed to fill another balloon of volume 33.6 liters under the same conditions? Now, 2 moles of helium gas, a balloon hold. How much balloon hold helium gas? That is 2 moles of helium gas, and its volume will become 44.8. So how many moles of helium gas are needed to fill another balloon of volume? Here the volume of the balloon is going to be changed, that is, and we are going to calculate the moles. So we are again, volume V1 is 44.8 and number of moles is N1 is 2 moles. Now here volume is becoming 33.6. So it means volume we are reducing. So moles are also going to be reduced. So we have to calculate N2. So then N2 is equals to, again cross multiply it. Then you know the crisscross method. N2 is equals to N1 into V2 upon V1. That is putting the values, all these values, what is given in the equations. 2 into 33.6 divided by 44.4. After cutting it, it will become 1.5 moles of a gas. So this way we can calculate the number of moles. So I have given you, I think, enough examples to understand the Avogadro law, and you can find more. You can solve the more numericals. It is given in the ICSE books or it is given in the CBSE books of the grade 11, which is the first chapter, some basic concepts of chemistry. In that given it is given over there, so you can find it too. You can also solve all these numericals. Next time again we will be here with the mole ratios, molar volumes, then how to calculate the moles. If the mole is given, what is the meaning of mole? All these things we are going to study over here. So I think this is enough for today. Try to understand all these things. Just if you have any problem anywhere, I will be there. You can text me so that I can take your problems. Thanks a lot. Keep well and keep studying.